microbial ecologist. I study the ecology of microbes in the environment. I'm interested in the processes they carry out that contribute to or detract from environmental quality. So the ways in which my research applies to NRES is through sustainability. So I'm interested in helping crops be more sustainable. I am interested in improving environmental quality and understanding how the ways that we manage land influences the microbial processes that affect environmental quality. So those are the primary ways. So a lot of what I do influences the nitrogen cycle and how we manage the nitrogen cycle on an agricultural landscape. Okay, I like that this is an applied ecology department at its heart. So I could have been in a microbiology department and I would have fit okay there, I think, but what I really get excited about is having a real-world problem that has a microbial ecology solution. And so in being in an environmental science department and having colleagues in engineering departments, so civil and environmental engineering, ag and bioengineering too, I have access to all these really great real-world problems that involve managing microbial communities and their activities and understanding the ecological drivers of microbial communities. What are those ecological drivers are we affecting through our land use and practices and ag management practices, and how can we do that better to better manage the microbial ecosystem services. When we restore wetlands, the restoration characteristics of wetlands, or assessment of restoration, is based on plant life. Are they wetlandy plants? Soil types, is it hydric soils, the kind of soils that we would expect to see in wetlands that have the signature of anaerobic processes and waterlog. And then the third is drainage. Is it a location that holds water for a while? So these are the assessments for wetlands. None of those assessments are based on ecosystem services, especially not microbial ecosystem services. And so there's this sense that when we have microbial, when we expect microbial communities to do a process, there's this field of dreams sort of approach. If you build it, they will come. And so the work that I do in restored wetlands is challenging that assumption. So are we really seeing a restoration of microbial communities and their ecosystem services? Do we have to see the same microbial communities in restored wetlands as we do in natural wetlands? And if they're not the same, are they at least carrying out the ecosystem services at a rate that we would expect? And what we're finding, initially we found that no, they weren't, but as the wetlands become a little bit more developed, we see a trajectory of improving ecosystem services such that we don't see a huge difference in the denitrification capacity between restored and natural wetlands. So that's good. But they also, these restored wetlands might be more vulnerable to changing environmental conditions too, because in the 2012 drought, we found that denitrification all around was just harmed by drought, but then they weren't, the following year when it was an exceptionally wet year, we didn't see the same pattern of recovery of ecosystem services in the restored and natural wetlands. So it seems like maybe the restored wetlands might have different vulnerabilities to climate change as well. Many days I ride my bike as often as I can. I live in downtown Urbana, so I walk many places. I walk to the grocery store, I walk to downtown. I buy much of my food at the local co-op, so a lot of that is locally sourced food, and organically farmed. I do also get groceries from Blue Apron, but they also have a locally sourced food. They support sustainable farmers there too. So those are some things that I do in everyday life. I live in a very small house. So my environmental footprint that way is pretty small as well. So early on, when I was a postdoc, the assessment of microbial communities was fairly challenging. And so a lot of times we would see people collecting one sample or from maybe one location in an ecosystem and saying, I have characterized the microbial community in this lake or this area. And one of the things that we did that I was really proud of when I was a postdoc is we carried out these time series. So we studied the microbial community over time, over seasons, over years, and we collected information about other ecological drivers that might impact or change at the same time, and try to understand these microbial communities. And so what we showed was that microbial communities change a lot over time. You can't just take one sample and say, I have characterized the microbial community. You can't just know anything about about microbial processes from just that one sample. And you sure can't know anything about the ecological drivers of microbial community from one time point without, you need to sample over time, see the natural variation. That gives you a baseline for understanding change in the microbial community and under environmental change scenarios as well. And so I'm really proud of my group's insistence on asking important questions, on thoroughness and application of ecological principles to the study of microbial ecology. So we're really, we find it really important to combine ecology, environmental science, and microbiology to bring to bear on the study of microbial processes. So we're really interested in looking at the ecological drivers and understanding which of those ecological drivers are things that we can manage or manipulate or are our fault, that can influence microbial processes that are important for ecosystem processes.